Welcome to Pure One, Chapter 14.6, where we continue with the logarithms. And this lesson, we're going to apply the four log laws that we've learned before. If you don't know, have a look in the previous video about the base law, multiplication law, the division law, and the power law, known as the power ranges of the log laws, of the logarithms. And we're going to use this. Okay, so to solve equations, you will see solving equation with logarithms. If not every year, it'll be once every other year in the exam series. So yeah, you will need to learn how to solve equation using logarithms, and it's quite a common exam questions. So notes, you'll need to solve different equations involving logarithms, and I'm going to show you how we can do that. The trick is to use the appropriate log laws to simplify to one single log before before we can solve it. So we can use these log laws, okay, to simplify down to one. Now, if you look at this log A plus log B help us to make it into one log. Log A minus log B down to one log again. And then what can we do with this? Now, once we use these laws, usually we can use the final law, the base law, to get rid of log, because this law, base law, helps you to remove the log, right? So that's the main thing the main one we can use to get rid of log as a final step. So anyway, example, solve the equation. Okay, log 4 plus 2 log x equals 2. So first of all, again, think about which law do you think we need to apply in here? Definitely the base law, as I just said afterwards. A few sentences ago. The power law, 2 log x, right? So we can use the power law to clean the log first. So log 4 plus log x squared equals 2. So in here, we are using the power law. Okay, the reason being is we don't want anything in front of the log. And why don't we want anything in front of log? Because then we can now use the multiplication law to put them together into one single log. Log A plus log B, log A, B. So multiplication law. Okay, so let me write that again. This is the base law, this is the multiplication law, this is the division law, and that's the power law. Okay, so then log, okay, so that's a base 10. So we can use the base law. Log AB equals C, A to the power of C equals B. That's the base law. And so we can solve the equation. So 10 squared, which is 100 divided by 4, 25, and then square root. So x equal plus or minus 5, actually. But we can't have negative in log, because if you remember the graph of log, okay, that's a log x log graph. Look like this. So that's the y equals log x graph. If you look at this, we can't accept, there's no negative x value, so we cannot accept the x value. So we have to reject the minus 5. So so x equals 5. Okay, so I'll put in here, we reject x equals minus 5 because cannot log negatives. Okay, log is such a positive, happy child. We can't log negatives. Okay, no negatives. If we try putting a calculator log negative 5, try putting a calculator log negative 5, it gives you a maths error. Okay, next one example. So 5 to the power 4x minus 1 equals 16. Give your answer in 3SF. So now x in the power. So we can apply log on both sides. So first of all, we'll do is we apply log on both sides. So we'll go log 5 to the power 4x minus 1 equals log 60. Now, why do I have to do that? The reason being is because x is in the power. So let's write down. So this is we apply log on both sides because x is in the power. So we have to solve exponential function, then the way to go is to log on both sides. Okay, so log, because x is in the power. So what can we do next? Well, then why do we use log? Because we can use power law. So we can now bring the 4x minus 1 down. 4x minus 1 log 5 equals log 60. So what we've done in here is we have used the power law. Okay, next, what can we do? Well, to make x subject, we can divide by log 5 across. So log 60 over log 5. And then you can do plus 1. So 4x equals log 60 over log 5 plus 1. And then divide by 4. So x equals to log 60 over log 5 plus 1 divided by 4. Now, put in the calculator. Okay, pause the video, put it in the calculator first, and see what you get. See if you're able to get 0.886. If you didn't get that, make sure to put a bracket around it. The base is 10. You can make any base, to be honest, as long as the base top and bottom is the same. But we usually use 10 as default. Okay, right. If you're happy with this, okay, pause the video, have a go at the practice question 1. Okay, let me actually copy and paste you the log laws, just in case you need it. Okay, so pause the video. Where should I put it? Here. Pause the video, have a go at the question. When you're ready for the answer, you can press play. Well, here's the final answer for the value of x. If you got it right, well done. That's the end. Okay, if you don't, I'm going to go through question by question. How do we do that? Okay, so first of all, A. 4 to the power of 2x equals 100. First thing first, we apply log on both sides. So we apply log on both sides because x is in the power. Okay, log 100. Okay, then we can use a power law. So 2x log 4 equals log 100. So to make x subject, we can divide log 4 and divide by 2. So x equals log 100 over 2 log 4. Just give you a hint. So this one here, we're applying here is power law. And then, yeah, we'll just make x subject from there. Okay. And then put in a calculator, it should give you 1.66. Okay. 1.66 3SF. Part B. Again, log on both sides. Log 3 to the power of minus 2x equals log 88. Use a power law, bring the power down. But because the power is a composite function, means there's more than one term polynomial. So put a bracket around it, and then log 2 equals log 88. We can divide log 2 across, so 3 minus 2x equals log 88 over log 2. And then in here, we can minus 3 and divide by negative 2. So x equals to log 88 over log 2 minus 3 divided by negative 2. Okay, so putting a calculator should give you x negative 1.73. But sir, did you not say in the last example we can't have negative 1 x can be negative? Well, partially correct. We can't have x being negative when you're logging it, when inside log. But because this x is just in the power, if you put in a calculator 2 to the power of 3 minus 2 times negative 1.73, it will work. You can have a negative power, but you can't have a negative log. A log negative. Okay, so part C. Part C. Log A plus log B. So straight away we can use the multiplication law. Log A B equals C. So multiplication law. Okay, so multiplication law. By the way, in here we use the power law. Okay. Next, so and the base law. Okay, log AB equals C. A to the power of C equals B. That's the base law. So 4 equals 3x divided by 3. So x equals to 4 over 3. Okay, nice and easy. D. What's it? D. Let me copy the question. 2 log 9 of x plus 1 equals to 2 log 9 of 2x minus 3 plus 1. Now, slightly trickier. First thing first, what we're doing here is, what do you think we should do? Well, to solve any log equations, we know we don't like to have the number in front. So we're going to apply the power law on both these two logs. Okay, first. So it becomes log 9 of x plus 1 to the power of 2 equals log 9 of 2x minus 3 squared plus 1. So power law. Okay, so power law. Power law. Okay, next, We want to bring all the logs on the same side, so we're going to subtract it on the left hand side. Okay, so it becomes log 9 of x plus 1 squared minus log 9 of 2x minus 3 squared equals 1. We're just bringing all the logs on the same side. So bring all logs to the same side. Okay. Log and then log A minus log B, same as log A over B. That's the division law. Okay. What's next? Well, I can use the base law to get rid of the log. So log A B equals C. So A to the power of C equals B. The base law. Now and then from here, to be honest, it should be fairly straightforward to solve it, which is you've got nothing to do but expand both brackets, top and bottom, okay, and then try rearrange it, make quadratic. So I'm just do it quickly in here. So x plus 1 squared. So the shock of a double for expanding double bracket is x squared, 1 squared, 1, and then multiply 2 times together. X times 1 is x, times it by 2 is 2x. Okay. Denominator, do the same thing. 2x squared. So square of 2 is 4x squared. Minus 3 squared is positive 9. For the middle term, 3 times 2x is 6x. Double it, 12x. It's a negative because you got minus 3 times 2. Okay, so if you struggle to listen to the shocker again, if you want to listen again, you can just rewind and listen to it again. Okay, what can we do next? Well, we can just multiply this denominator to the left-hand side. So 9 bracket 4x squared minus 12x plus 9 equals x squared plus 2x plus 1. And then we just have to go on expand bracket. So 36x squared minus 108x plus 81 equals x squared plus 2x plus 1. Bring everything to one side. 35x squared minus 110x and then plus 80 equals 0. It's tempting to divide by 5, but actually remember we are now in A level. We can use our A level calculator. We've grown up. Okay, we don't have to rely on quadratic quadratic formula or anything like factorization. Those shenanigans. We're going to use the calculator and put in a calculator. You should get x equals 2 or 8 over 7. Okay, moving on. Okay, different type of equation. 5 to the power of 2x minus 12, 5 to the power of x plus 20 equals 0. Now, I'm not sure if you remember what a disguised quadratic. What is a disguised quadratic? Okay, this is actually a quadratic equation because you can see the power, the ratio of power in this one is 2 to 1. If you look at the power of in the x, 5 up 2 to x and 5 to the power of x is 2 to 1. So that's a disguised quadratic. So it's a disguised quadratic. What does that mean? That means it is a quadratic, but it's just blended in a way that you have to be able to let y to be something to be middle term, so it changes into a quadratic. So in here, as I said, we can let y to be middle term, 5 to the power of x. We've done something similar in the trigonometry chapter, where we solve some trigonometry equation. I think it's 10.5 or 10.6, chapter 10.5, 10.6, I can't remember. So let y equals 5 to the power of x. So 5 to the power of 2x therefore becomes y squared. Well, why? Well, if you think about it this way here. Okay, where's it gone? If you think about, where's the mouse? Mouse not working. The mouse just ran off battery. But anyways, if you think about in here, but let me finish this line. So y squared minus 12y plus 20 equals 0. Well, where's the y squared come from? Think about this. 5 to the power of 2x is the same as 5 to the power of x squared, right? 5 to the power of x is y, therefore it's y squared. Okay, and then what can we do? Well, put in a calculator. Okay, put in a calculator, it's a quadratic. So you get y equals to 10 or y equals to 2. But we were not interested in y, we were interested in x. So we replace y back into 5 to the power of x equals 10 or 5 to the power of x equals 2. To solve this equation, you have learned about Bayes' law. A to the power of c equals b. Therefore, log 5 to the power of 10 equals x. Right, this is a Bayes' law. So this is the base law. Hopefully you remember that. Okay, so I'll show you one way. Put in a calculator, log 5, base 5 of 10, you get 1.43. Now, there's a different way. Actually, let me put calculator double check my answer. Log base 5 of 10 is indeed 1.43. There's another way to do this. Okay, this method number 1. This method 1 depends, this method 1. Method 2. Okay, method 2. We apply log on both sides. Depends which one log on both sides. Now see which one you like. Both ways perfectly work. Okay, so we apply log on both sides, becomes log 5 to the power of x equals log 2. Then to bring the x down, we can use the power law. So log 5 equals log 2. So x equals to log 2 over log 5, which you put in the calculator is 0.431. So you can either, okay, apply the base law, okay, or you can apply log on both sides. Okay, so I'll show you both ways and then apply the power law in here. Okay, so yeah, right. One more example. Okay, so example, solve 3 to the power of 2x plus 1 minus 17, 3 to the power of x plus 10. So what's the difference in here? The difference with this, the new example in the previous one is that, look at the power, that's 2x, this 2x plus 1. So we can apply a very clever trick, okay, so we can write this as 3 to the power of 2x times 3 minus 17 times 3 to the power of x, nothing else changes, plus 10 equals 0. Well, where would that come from? Well, think about this. Okay, so think about this. Okay, e.g., if you've got x to the power of 7, which is x to the power of 5 plus 2, you could write as x to the power of 5 times x to the power of 2. So same thing, 3 to the power of 2x plus 1 in the power, we can break it out into 3 to the power of 2x times 3 to the power of 1. All right? Then this becomes a disguised quadratic. So, then it becomes a disguised quadratic. So this then a disguise, and this is now become a disguised quadratic. Well, we can let y equals 3 to the power of x. Okay, so this 3 to the power of 2x becomes y squared. So y squared times 3 minus 17y plus 10 equals 0. So 3 to the power of 2x, 3 to the power of x is y. So I'll color code it for you so you can see what changes. Okay, next, well, I can rewrite 3y squared minus 17y plus 10 equals 0. And then just put in a calculator. Okay, put in a calculator, you get y equals to 5 or y equals to 2/3. Same thing, again, we can rewrite as 3 to the power of x equals 5 or 3 to the power of x equals 2/3. We rewrite y as 3 to the power of x. Then you can use your own way. Pause the video now, see if you're able to learn from a previous example how to solve this equation. Okay, if you don't, I'm going to go through it. Okay, you can pause the video now and see if you get the answer. So what we can do in here is we can apply the base law. So x equals to log 3, 5. Okay, a to the power of c equals b, so log ab equals, yep. So x equals to 1.46. In here, you can also do the same thing. It'll be log base 3 of 2/3, or x equals negative 0.369. Or, okay, if you want to use, just show you, or you can do log 3 to the power of x equals log 2/3. So x log 3 equals to log 2/3. X equals to log 2/3 over log 3, which you get negative 0.369. Same thing. Okay, that's it. Right. Now we've gone through, to discuss quadratic equation about logarithms. So your turn. Okay, pause the video, have a go at the question. Okay, when you're ready for the answer, you can press play. Well, here are the final answers. Okay, if you got it right, well done. Good for you. Well done. Then you can have a go at the challenge question next page. But if you don't, let's have a look. Okay, question A. So first of all, again, discuss quadratic. The first one is quite a simple one, we're straightforward one. In question A, we can let y equals to 2 to the power of x. You always let y to be the middle term. So then we have y squared minus 6y plus 5 equals 0. Okay, put in a calculator, you should get y equals to 5 or 1. So y equals to 5 or y equals 1. We substitute 2 to the power of x into y. Okay, then in here, so x equals to log to 5 or x equals to log to 1. So log 5, put in the calculator, you get 2.32. Now if the question say exact value, okay, if the question say exact value, we can leave it like this, log 25. But because the question wants a 3SF, we write as 2.32. Log 1. So anything log anything, base anything of 1, log 1 is always 0. That's 0. Well, why? Because 2 to the power of 0 is 1. Anything to the power of 0 is 1. Okay, hence the answers. Okay, question B. Slightly trickier. 7 to the power of x plus 1, we see the power. Let me copy the question. We can rewrite this as 7 to the power of x times 7. Okay, can break it down. Then we can discuss quadratic. We let y equals 7 to the power of x. So it becomes y squared minus 7y equals to minus 12. Bring it all to one side. And there should be the same thing like the previous one. You should get y equals to 4 or 3. So 7 to the power of x equals 4 or 7 to the power of x equals 3. So from here, so x equals log 7, 4 or log 7, 3. So x equals to 0.712 or 0.565. Right? Part C, slightly trickier. 4 to the power of 3x. Let me copy the question. And here, question C. 4 times 3 to the power of 2x plus 1 plus 17 3 to the power of x minus 7 equals 0. So again, we see the 3 to the power of 2x plus 1, we see a plus 1 in the power. We have to use that trick where we split the power. Plus 17 3 to the power of x. Right. Next, we can expand the bracket. 4 times 3 is 12. So it's 12 lots of 3 to the power of 2x plus 17 3 to the power of x minus 7 equals 0. Now, I know some of you might be asking me a silly question. Oh, why don't you do 4 times 3 to the power of 2x? You know, what about the 4 times 3 to the power of 2x? Now, they're all multiplied together. So to answer this silly question, okay, just in case you have it, is that if you have, imagine you've got 4 times 2 times 3, then you can do it the same as 4 times 3, which is 12, 12 times 2. Okay, so you don't have to do 4 times 2 as well. You're not going to multiply again, right? So that's the same thing. Okay, so next, 12, then we can discuss quadratic. Okay, so we can let y equals 3 to the power of x. So it becomes 12y squared plus 17y minus 7 equals 0. Put that in the calculator. You get y equals to a third or negative 7 over 4. So 3 to the power of x equals a third or 3 to the power of x equals negative 7 over 4. Okay, so x equals to log 3 of a third or log 3 of negative 7 over 4. If you remember what I said, you can't log a negative, so you're going to reject that one. That will give you a maths error. Okay, so put this in the calculator, you get minus 1. Okay, and that's it. Okay, so next one. Okay, pause video, have a go at challenge question. Okay, if you're there, but if you don't want to do the challenge question, feel free to finish the video now and have a go in your homework. Otherwise, okay, pause the video, have a go. When you're ready for the answer, you can press play. Here's the final answer. So x will equal 0.792 or negative 0.5. Or if you're wondering how, okay, so if you struggle to start, let me give you a hint. Okay, what about rewriting power of negative x back into positive power, back to the fraction? So 2 times 4 to the power of x plus 3 times 1 over 4 to the power of x equals 7. Okay, if you want to try again, pause the video anytime now. Okay, and have a go. Well, what else can we do? If you're still struggling, I'll give you a bit of hints as well. Okay, think about how you solve this equation. Just for example, I'm just giving it out. Okay, just give out any any equation for a similar one. So think about how you solve this one. Okay, think about how you can solve this one. Right, I can actually draw some inspiration from this one. Now, if I have a y denominator, what I would do is I will multiply everything by y because I don't like my variable in denominator. Right, so in this case, I will multiply everything by y. So y times y is y squared. 1 over y times y is 1. 5 times y is 5y. Then it becomes a quadratic. So we can draw inspiration in here to the same thing. We can multiply everything by 4 to the power of x. Okay. Well, what does it look like? Then 2 times 4 to the power of x times 4 to the power of x becomes 2 times 4 to the power of 2x. How? In here, 4 to the power of x times 4 to the power of x is same as 4 to the power of x plus x, which is same as 4 to the power of 2x. Okay, so we'll multiply everything by 4 to the power of 2x, 4 to the power of x. Again, the reason being is we don't like 4 to the power of x in the denominator. The 1 over 4 to the power of x and 4 to the power of x cancel out. This one is 7 times 4 to the power of x. There you can see it becomes a disguised quadratic. So if we bring the 7 times 4 to the power of x left hand side, it becomes 2 times 4 to the power of 2x minus 7 times 4 to the power of x plus 3 equals 0. We can then let y equals to 4 to the power of x. So that becomes 2 times y squared plus minus 7y plus 3 equals 0. And then from there, you should get y equals to 3 or 0.5. So y is 4 to the power of x, so 4 to the power of x equals 3 or 4 to the power of x equals 0.5. So x equals to log 4, base 4 of 3 or log base 4 of 0.5. In this case, you get 0.792 or negative 0.5. All right, and that's the end of this chapter. Again, you will be examined nearly every year on logarithm equation, whether it's discussed quadratic or simpler ones where you have to put all the logs on one same side. Okay, so make sure you do a lot of practice to consolidate this.